Chapter 1, Introduction to Pipe Welding. The objectives for this chapter are: after completing this chapter, the student should be able to describe the history of pipe welding systems, list the four different major categories of piping systems, explain the various specifications that may be used to specify pipe and tubing, discuss the differences between the three basic groups of pipe welds, explain the system of pipe schedules, list the three general areas that pipe welding jobs may be divided into, and then finally discuss the importance of teamwork for pipe welders. Introduction. The earliest piping systems were built by the Greeks approximately 5,000 years ago to provide water to the residencies on the island of Crete. Later, as the Roman Empire began to develop, the Romans expanded the Greek clay piping systems of fresh water to include a separate system of drain pipes throughout the city. These early Roman clay piping systems were gradually replaced with lead pipe. The artisans of the day developed a new process to weld sections of the lead pipe together. Over time, much of the ancient city of Rome was plumbed for water through these lead pipes. Fortunately for the Romans, their water had a high mineral content that quickly coated the inside of the lead pipes, preventing lead poisoning. Small diameter lead pipes were used throughout Europe and in many of the older cities in the Americas, including New York. New York City, Boston, and Montreal. Water mains were eventually constructed by hollowed out logs. Later, large water mains were made much like very long wooden barrels. Workers used narrow wood strips held together with metal bands tightly wrapped around the outside. Figure 1-2. Over time, the lead pipes were removed. However, a few of the early wooden water mains that were constructed are still in service. These days, there are millions of miles of pipe used in a wide range of applications throughout the world. The ancient world was limited to only a few materials such as clay, lead, and wood. But today, pipe can be made from many popular materials such as cast iron, steel, stainless steel, copper, brass, plastic, glass, fiberglass, and concrete. In this textbook, the major concentration will be on fitting and welding steel pipe because the skills learned with steel pipe can be transferred to stainless steel, aluminum, and other metal piping materials. Piping systems. Piping systems can be divided into four major categories: collection, transportation, distribution, and processing. Collecting piping systems have smaller pipes joining larger pipes as the material in the smaller pipes combine, thus requiring a large pipe to handle the flow. Some examples of collecting piping systems are sewer pipes from various appliances in the home, stormwater drain pipes in the neighborhood or city, and oil field piping, where pipes collect product from various wells for storage and processing facilities. They are usually buried beneath the Earth's surface and can be seen only where they surface at pumping and pressure regulator stations. Some examples of transportation pipelines are water pipes that are used to move raw water from reservoirs to water treatment plants, fuel lines that move gasoline, diesel fuel, and jet fuel from coastal refineries to distribution facilities inland, and the Alaskan pipeline, which moves crude oil 800 miles from Prudhoe Bay to the harbor at Valdez, way through, excuse me. Distribution piping systems have smaller individual pipes connected to large mains. They are used to deliver products such as natural gas and water for homes and factories, compressed air for pneumatic tools, shielding gases for welding, and chilled water for air conditioning. For many years, a brewery in Germany moved beer directly from its plants to nearby stadium through a distribution piping system. Process piping systems can be very diverse in size and materials. The diameter of some pipes may be used as small as a fraction of an inch or a few millimeters, all the way through several feet or meters in diameter. The smaller pipes may be used to supply a chemical agent or other such material from a storage tank to a processing vat. The large pipes are used to move products through a manufacturing facility or refinery. Examples of process piping systems can be found in oil refineries, paint manufacturers, cosmetic manufacturers, and many food processing plants. Pipe applications. Tubing is most often used to build items such as a bicycle, motorcycle, race car, and an aircraft frames, handrails, and playground equipment. However, pipe is used for many of these applications too. Both are used for structural applications or ornamental or decorative art. Excuse me. Examples of structural applications are a walkway between a hospital and a parking garage in Columbia, South Carolina, figure 1-8, and the framework for pyramid buildings at Moody Gardens in Galveston, Texas. Figure 1-9. Examples of ornamental applications of pipe include the farm post shown in figure 1-10. Examples of decorative art include the windmill shown in figure 1-11. A pedestrian crosswalk over a major city street makes a downtown safer. Modern pyramids built on frameworks of piping and tubes. Rain gauge or hummingbird feeder pipe garden posts, and a windmill built out of 1/2 inch electrical mechanical tubing. How pipe is made. Pipe can be manufactured as seamed or seamless. Seamed pipe has a longitudinal weld along its full length. It is formed from flat plates that are first heated, then pressed through rollers that bend it into pipe shape. Resistant seam welding machines use rollers to pass the welding current through the pipe and to fuse the edges of the plate together, forming the longitudinal weld. Figure 1-12, seam pipe manufacturing technique. A cutter removes the small amount of weld flash from the outside of the weld. The small weld flash on the inside of the pipe may or may not be removed. The pipe is then cut into sections. Seamless pipe is formed so there is no need to make a longitudinal weld. It is made by forcing heated metal through a forming die that has an internal mandrel to form the center opening in the pipe. Figure 1-13 shows both seamless and seamed pipe sections are thoroughly inspected following manufacturing to ensure that they are sound. Both types of pipe are incredibly strong and they can provide years of reliable service. Seamless pipe manufacturing technique. Spiral pipe is formed of long coils of hot rolled steel that are wound into a long spiral, much like the cardboard tube in the center of a roll of paper towels. Figure 1-14 shows spiral pipe manufacturing technique. As the metal coil is unwound, its edges are trimmed and beveled so that it forms into a round cylinder. The two edges form a double V groove. The V groove is the first welded on the inside and then on the outside using a process known as submerged arc welding. Once the pipe is welded, it is cleaned of all flux and the welds are thoroughly inspected before it's heat treated and coated. Pipe versus round tubing. Pipe and round tubing are not the same, although they can appear the same and maybe use similar applications. Pipe is primarily used to move both liquids like water, gasoline, oil, and other petroleum products, and gases like air, steam, and engine exhaust. In addition, tens of thousands of other products are safely and efficiently moved through millions of miles of pipe every day. Round tubing is used for both structural applications and to move fluids. Tubing is the structural component of many common products such as classroom and office furniture, highway guardrails, playground equipment, and roller coasters. Pipe and round tubing are different in the way they are specified. All or part of the following pipe and round tubing specifications may be included on a bill of materials or a material specification sheet. For example, the weight of pipe or round tubing, usually expressed as pounds per foot or kilograms per meter of pipe, may be written in the specifications but is not often included since it can be found on most pipe charts. Pipe standards. One of the major differences between pipe and tubing is how the material is specified. The American Standards Association, now the American National Standards Association, ANSI, first standardized the dimensions for steel and iron pipe and tubing. There were few applications for pipe, so only a few different pressure ranges were available. The various pressure ranges determined the thickness of the wall of the pipe. Figure 1-17, diameter and wall thickness versus pressure. The original standards only included standard, extra strong, and double extra strong. Today, standard pipe is often Schedule 40, extra strong pipe is often Schedule 80, and double extra strong pipe does not have a schedule number. Table 1.1 shows the various pipe schedules and wall thicknesses for a variety of pipe diameters that are available today. Changes in the marketplace have resulted in a significant increase in the various pressure ranges and wall thicknesses of the pipe. Some of the things that have affected the wall thickness of the pipe are changes in the material and application. Since stainless steel pipe, which was first introduced in the 1920s, is much stronger and less likely to have corrosion, reduce the thicknesses of the pipe over time. This allows much thinner wall sections for the sample schedule. In addition, thinner walled sections of pipe were introduced for applications other than critical, such as drainage, ornamental, or decorative work. One drawback to the thinner sections is that they cannot be threaded because of the thinner walls. Pipe specifications. Typical pipe specifications include length. This is the overall length of the section or piece of pipe. Common lengths for steel pipe are 10, 20, and 21 foot. Diameter. The inside diameter dimension is given for the pipe that is smaller than 12 inches in diameter, and the outside diameter OD dimension is given for pipe that is 12 inches or larger. The actual diameter of the pipe may vary slightly because of many factors. Therefore, the term nominal pipe size is used for standard pipe, and diameter nominal is used for metric pipe. Here's a look at the schedule and wall thickness in dimensional inches. Pipe schedule and wall thickness. So if we look at schedule 20, wall thickness. Pipe wall thickness was originally standardized back in 1939. The early system used a system of schedules that were related to a pressure range. The basis of that original system grouped pipe into three pressure ranges: standard, extra strong, and double extra strong. The current standard for pipe wall thickness is the National Pipe Standard, Table 1-1. Note on the chart that the current system still has some relationship to the early terminology, but it is important to note that now there is not a pressure range relationship, i.e., a Schedule 40 standard steel pipe has a high pressure range than the schedule, or it's a higher pressure range than the Schedule 40 PVC pipe would have. Material. The American Society of Mechanical Engineers, or ASME, has a number of specifications that cover a wide range of materials and methods of manufacturing pipe. The ASME specifications range from AS 135 for electrical resistance welding steel pipe to AS 378 for seamless, authentic, high pressured, high temperature pipe. Fittings. The ends of pipes can be joined by different methods such as butt welded, socket welded, or threaded. Pipe dimensioning. The ASME standard for pipe scheduling lists the outside diameter of the pipe, and the wall thickness can vary based on the schedule. Therefore, the inside diameter of a 6-inch Schedule 40 pipe is slightly larger than the inside diameter of a 6-inch Schedule 80 pipe. The system is used on pipe from 1/8 inch in up to 12 inches. Above 12 inches, the outside diameter of the pipe is given, and the wall thicknesses changes the inside diameter of the pipe. Round tubing specifications. Generally, tubing has a more rigid set of specifications as compared to most pipe. Tubing specifications may include material. Tubing is available in a number of different types of metal, as well as the other materials such as plastic, rubber, silicone, fiberglass, composite, and glass. ASTM International, formerly the American Society of Testing of Materials, has established standard specifications that cover most types of metal tubing. Diameter. The diameter of tubing is always expressed as the outside diameter. ID versus OD for pipe diameters. 12-inch and less inside diameters. More than 12 inches outside diameter. All tubing is outside diameter. Wall thickness. The wall thickness of rigid round tubing may be given as a gauge thickness or as a specific dimension. Shape. The shape of tubing must be specified because it is available in shapes other than round, such as rectangular, square, oval, and wide range of specialty shapes. Length. Rigid round tubing can be purchased in lengths ranging from 5 to 24 feet, and flexible round tubing can be purchased in coils ranging from few feet to several hundred feet. Common lengths for flexible tubing are coils of 25 to 50 feet. Pressure range. Because some types of tubing are designed to carry pressurized fluids, a pressure range of these tubes would be included in their specifications. Temperature range. The operating temperature range for the minimum or maximum service temperature are important because both high and low temperatures will affect the performance of the tubes. Bending radius. The minimum bend radius of a tube can be a major determination in the selection, since tubing is often bent to a particular shape before welding. Strength. Tubing that is designed to be used in structural applications will include the tensile strength, bending strength, compression strength, and other characteristics as needed for particular applications. Finish. Tubing is available in a variety of surface finishes, including cleaned, galvanized, polished, and coated. Temper. Annealed tubing is soft and more easily bent, or shape than half-hardened or fully hardened tubing. Half-hardened and fully hardened tubing is often referred to as rigid tubing. Application. The intended application of tubing will affect the available or approved types in some cases. Aerospace and aircraft tubing must have certification paperwork that must be kept with the tubing throughout the fabrication process, all the way to the final customer. Some of the applications that can be specified for tubing include general purpose, automotive, chemical, cryogenic, food and beverage processing, medical, and oil and fuel, among others. Tubing dimensions. Round tubing is specified by the outside diameter and wall thickness. So a 6-inch diameter tube with a quarter-inch wall thickness could possibly fit inside a 6-inch Schedule 40 pipe. It is possible then to have a 14-inch diameter pipe and a 14-inch diameter tube that would have the same wall thickness if the tubing wall thickness was specified to be the same as the pipe. Pressure and strength ranges. In the textbook, pipe welded joints are grouped into 3 general categories based on their strength requirements for both piping systems and structural applications. These groups are loosely based on the level of critical service that the pipe is performing. Basically, the groups related to the degree or extent of injury, properly damaged, or both that might happen in a catastrophic failure of the weld joint were to occur. The 3 general categories are low pressure or light duty service, medium pressure or medium structural service, or high pressure or heavy structural service. Low pressure piping systems may be used for collector systems such as wastewater systems, agriculture irrigation systems, and building sprinkler systems. Light duty service pipes may be used for bicycle stands, agricultural fences and gates, the art sculptures. If a catastrophic failure occurred in a low pressure piping system or light structural service application, there might not be some property damage, but little chance of injuries. There might be some property damage, but little chance of injuries. Medium pressure piping systems may be used for water supplies, compressed air, and residential gas distribution. Medium structural service pipes may be used for signpost, railroad crossing signals, figure 1-20, and truck brush guards. If a catastrophic failure occurred in medium pressure systems or medium structural service applications, there would be some property damage and there could be some minor injuries. High pressure piping systems may be used for cross-country transmission of oil, gasoline, and natural gas, oil refinery, and high pressure steam pipes in power plants. High strength service pipes may be used for aircraft engine mounts, building frameworks, and tank support legs. A catastrophic failure in a high-pressure system and a high-strength structures will result in significant property damage and can result in serious injury or possibly death. So the welding requirements for each of these systems varies from low-pressure systems with a visual inspection, medium pressure with a little greater scrutiny, and a high-pressure system that would be thoroughly tested. Figure 1-21, X-ray testing of pipe welds. Pipe system codes and standards. The American Petroleum Institute API 1104 code is one of the most widely used piping welding standards in the industry. Excuse me. It is used for both structural and piping applications. The American Welding Society D.1.1 structural welding code has specifications for structural pipe applications. These applications can vary from a system that is primarily ornamental, such as a piece of art or yard decoration, to something that's more critical, such as a handrail or a guardrail, to an application that would be critical if it failed, such as a crosswalk or a structural building components. Pipe welding processes. All of the major welding processes can be used to weld pipe. The most important factor to consider then when selecting a welding process is the applicable codes and standards. But within these codes and standards, there are opportunities to make choices between different welding processes. Some of the other factors that should be considered when selecting the welding process include the pipe diameter and schedule, the pipe material, whether the welding will be done in the shop or in the field, and the number of welds that will be required. Steel pipe that is an inch or less in diameter can be oxyacetylene welded, gas tungsten arc welded, gas metal arc welded, or flux core arc welded. But if these but with these small diameter pipes, shielded metal arc welding can be a difficult process. Large diameter pipe and thick walled pipe cannot be oxyacetylene welded efficiently, but almost any other welding process can be used. Stainless steel pipe can be welded with TIG, MIG, or flux core. Aluminum pipe is usually welded with TIG. The textbook will cover stick, TIG, MIG, and flux, which are the most commonly used welding processes for pipe welding. Types of pipe welding jobs. Pipe welding jobs can be divided into three general areas: manufacturing, construction, and pipeline. Each of these general job groups has its own skills, opportunities, and requirements. Manufacturing pipe welding jobs. Examples of these pipe welding jobs include welding many common products ranging from motorcycle frames to booms for cranes and many other items. Table 1-2, pipe welding items that are manufactured with pipe. When the size and the shape of the parts being manufactured allow the use of welding positions, the welds can be made in the rotated flat position 1G. Because the pipe welder does not have to transition between welding positions, 1G pipe welding is considered to be easier than other welding positions. Many manufacturing companies have climate control work areas, so welding in the summer is not too hot and welding in the winter is not too cold. For many welders, manufacturing jobs offer the convenience of not having to travel to different job sites. These jobs also offer the stability of working with the same people. Because production requirements may be high, the welders may be required to weld for longer periods of time than welders working in other types of jobs. Construction pipe welding jobs. Examples of these welding jobs include constructing oil refineries, chemical plants, boiler room piping, and many other structures. Table 1-3. The size and complexity of construction projects can vary greatly. Some nuclear power plant construction projects may last for years, while pumping station job may only take a couple of weeks. Construction at a power plant or refinery will require a great deal of skill to make quality welds on various types and sizes of pipes, as well as requiring welders to weld in all positions while in some cases working around obstructions. In addition to welding skills, welders often must be comfortable working high above the ground. Almost all construction jobs require traveling, and some may stipulate that the welders relocate to a different city or state. There may be little protection from the rain, heat, cold, wind, snow, or other weather conditions. From the first day on the job, construction welders are working themselves out of a job. When the building is finished, they have to look for another job. Pipeline welding jobs. Examples of these jobs include all types of cross-country pipelines. Figures or table 1-4. Pipelines can range in length from a mile or less to hundreds of miles. They may also range in diameter from an inch or two to several feet in diameter. In most cases, the pipe is welded above ground or above grade. but welders may be required to work in open trenches. Much like construction welders, pipeline welders may be required to travel or relocate and work in all types of weather. Teamwork. There's a lot of work that needs to be done to make a weld on large diameter pipe. Often there is more work than a single welder can do in a timely manner to meet the scheduled deadline. So most pipeline welding jobs and many pipe construction welding projects are often done by a crew. Figure 1-22. It takes teamwork to move large pipe sections into place. The crews are made up by welders and helpers, all of whom take directions from the site supervisor. On large jobs where several welding crews are working, the supervisor may be the project engineer. On smaller crews, the pipe welder is the person in charge of the welding crew. Each member of the crew has a specific job responsibility. The welder acts as the leader and directs the other crew members. The welder helps assist with the preparation and fit up of the pipe joint. They are also responsible for the wire brushing and grinding the weld between weld passes and weld crater cleanup, if needed, before the new electrode is started. The welder helper may also be responsible for making small adjustments in the welding amperage settings as requested by the welder. A crew member may serve as a fire watch. The fire watch's primary responsibilities are to make sure that the site is safe so no accidental fires get started. Also to alert the welder and sound the alarm if a fire does occur, and be prepared to use the available fire extinguisher to put out the fire. When all of the combustible materials cannot be removed from the welding area, this person may wet them down or cover them up. Other crew members may operate equipment to lift and place the pipe joints and pipe sections in place, as well as performing other tasks that are required. Leadership. A team leader must have knowledge of the equal employment opportunity laws regarding job discrimination and make sure that these laws are followed. A good team leader should have a positive attitude, think and plan ahead, treat everyone with respect, show confidence in crew members' abilities, and most important, communicate clearly to each member what is expected of him or her. It is important to recognize the various strengths and weaknesses of each crew member so that the person can be used in the most effective manner to get the job done. When necessary, leaders should coach crew members in how they want them to do their jobs. Often demonstrating the proper way to do something can be helpful. A crew that works well together will be such more productive than one that is dysfunctional. As crew leaders, you need to be able to help resolve conflicts between team members, identify the key issues that might be causing the conflict, and get the crew to agree on how the problem can be resolved. A work crew's performance is usually evaluated by the productiveness of the team, so hard work and cooperation are rewarded. Metric units. Both standard and metric units are given in the text. The standard or SI units are in parentheses following the standard units. When non-specific values are used, for example, set the gauge at 2 psi, where 2 is an approximate value, the SI units have been rounded to the nearest whole number. Round off occurs in these cases to agree with the standard value, and because whole numbers are easier to work with, SI units are not rounded off only when the standard unit is an exact measurement. Often students have difficulty understanding metric units because exact conversions are used when the standard measurement was an approximation. Rounding off the metric units makes understanding the metric system much easier. By using the approximation method, you can make most standard to metric conversions in your head without needing to use a calculator. Once you have learned to use approximations for metric, you will find it easier to make exact conversions whenever necessary. Conversions must be exact in the shop when a part is dimensioned with one system's units and other systems must be used to fabricate the part. For that reason, you must be able to make those conversions. Tables 1-6 and 1-7 are set up to be used with or without the aid of a calculator. Many calculators today have built-in standard metric conversions. It's a good idea to know how to make these conversions with or without these aids, of course. Practice making such conversions whenever the opportunity arises. Formulas for calculating exact conversions in standard metric. Summary. Pipe welding offers welders a wide range of opportunities for jobs and a wide range of industries. It can also be one of the most rewarding welding fields, both personally and financially. The high quality welds require the most pipe welders or weld the high quality welds require for most pipe welding let welders truly demonstrate their welding abilities. Completing a high quality pipe weld job can be very personally rewarding. Because of the high level of skill required for many pipe welding jobs, these welders receive some of the highest rates of pay. The diversity of the job will allow pipe welders to work in a single area for years or allow them the freedom to travel and experience different parts of the country.